We could write this big number in extended form rather than writing it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2.3456. We could write it as 100 billion plus 2 times 10 billion plus 3 times a billion plus 4 times 100 million plus 5 times 10 million, and so on. So let's actually write that down so you can see it. Let's try using a different color. So this would be one lot of 100 billion. Plus 2 lots of 10 billion. Plus 3 lots of 1 billion. Plus 4 lots of 100 million. Plus 5 lots of 10 million. Plus 6 lots of 1 million. Plus 7 lots of 100,000. Plus 8 lots of 10,000. Plus 9 lots of 1,000. Plus no lots of hundreds, so I don't have to write that because I'm not adding anything there. Plus 1 lot of 10 plus 2 ones plus 3 lots of a tenth plus 4 lots of 100th plus 5 lots of 1,000th plus 6 lots of 1/10,000th. Now that was a long way of writing it out, and it's slow and it takes up a lot of space because of all these zeros. So we have a more succinct way of writing these numbers. I can say that this is, I'm going to write it as 10 to the power of, now to know what I want to write up here, I'm going to count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 10 followed by 9 zeros. This is 10 followed by 8 zeros. 10 followed by 7 zeros. 10 followed by 6 zeros. And so on. 1,000 is 10 followed by 3 zeros. 100 is a 1 followed by 2 zeros. 10 is a 1 followed by 1 zero. And 1 is a 1 followed by no zeros. So the little, you write a 10, but then the index tells you how many zeros are following the 1. So I've got 1, then 9 zeros, 1, then 8 zeros, 1, then 7 zeros. This pattern actually keeps going down here, but what I'm going to say is minus 1 zeros. The minus tells me to make it 1 over. So what it's telling me is to make it 1 over and then write 1 followed by 1 0. So to do this one, I'm going to make it 1 over, and then I'm going to write a 1 followed by 2 zeros. So I can represent that as 10 to the minus 2. This pattern just keeps going down like this. And this gives me a shorter and easier way that I can write that big number in expanded form if I want to. I could say it's 1 times 10 to the 11 plus 2 times 10 to the 10, and that's because 100 billion is 1 followed by 11 zeros, and 10 billion is 2 followed by 10 zeros, plus 3 times 10 to the 9, plus 4 times 10 to the 8, plus 5 times 10 to the 7, plus 6 times 10 to the 6, plus 7 times 10 to the 5, plus 8 times 10 to the 4, plus 9 times 10 to the 3. Now I'm going to write this one in even though I don't have to. I could just leave that out, but I've got nothing times 10 to the 2. No, just, I'll say we could leave this out. I'm just putting it in there so you can see the full pattern. There's none of it, so I'm not adding anything. And if I'm adding 0, I don't have to write it. Okay, plus 1 times 10 to the 1 plus 2. Now again, I'm going to write 10 to the 0 just so you can see the pattern following, but there's no need to write that. I can just write 2 if I want to, and that's completely fine. I'm just writing out the times 10 to the 0, which means timesing by 1 followed by no zeros, which is times 1. So it's not necessary, but it lets you see how the pattern's going. And then I can keep going with the numbers to the right of my decimal point. I could have plus 3 times 10 to the minus 1 plus 4 times 10 to the minus 2 plus 5 times 10 to the minus 3 plus 6 times 10 to the minus 4. And there's our number again written in expanded notation form, but somewhat more succinctly. What this does is it shows you exactly the contribution of every digit in the place value system. Once we know what the places are called, we can have a look and answer simple questions like, what's the digit in the millions place? We look through till we find the millions place, come down and we see it's 6. What's the number in the tens place? Come up till we find the tens, come down and see it's a 1. What place is the 7 living in? There's our 7, follow it up. It's living in the 100,000ths place. So this number contains 700,000s.